Glaciers are really fantastic at sculpting the landscape, and they're also really great at leaving behind lots of depositional evidence that they have been there. Let's look at some of these features. Okay, let me turn my face off. Before glaciation, this mountainous area with a couple of streams kind of looks like the Appalachian Mountains. Glaciers come in and fill in the valleys with ice. During that time, the glaciers are going to be moving over the landscape. They're going to be abrading. Abrasion occurs when fine and coarse-grained rocks get embedded in the ice. If it's fine-grained sediment embedded in the ice, that will act to polish the bedrock surface it's moving over. If it's chunky, big gravel pieces or boulder pieces embedded in the ice, that will act to scratch the bedrock surface. Plucking occurs when the ice freezes onto the rock. Then it continues to move and pulls off chunks of the underlying bedrock. The polished surface then can look something like this, kind of a shiny surface. There can be chatter marks, these kind of places that look kind of swoopy here, and this is where boulders have perhaps dug into the face of the rock. Striations are like these scratches along the rock surface here. Okay, the U-shaped valleys are going to occur when a glacier is moving through the valley. It is going to erode not just the valley floor like a stream. It also is eroding the sides of the valley, so the valley turns into a U shape. If that U-shaped valley is then flooded, it's called a fjord. Here's some other landforms that are formed on the edges of the glacier. Here's some other landforms that can form. An arête is like a knife edge where two glaciers have moved in valleys next to each other and left a skinny blade of rock in between them. A horn is going to occur where maybe 3 or 4 glaciers have eroded steep sides to valleys and left a pointy mountain in the middle. A cirque is this bowl-shaped top of the valley. Sharp mountain profiles, right? It carves these mountains into sharp points, whereas before it kind of had a topography like the Appalachian Mountains. Where one of these tributary glaciers runs into the main valley glacier, there can be a waterfall. So the main valley glacier has eroded this U-shaped valley pretty deep. The tributary glaciers didn't go as deep, and so we have a hanging valley that has a waterfall coming out of it. Here is a cirque at Glacier National Park, the head wall of the glacier. A cirque, here's the head wall, is going to occur when there's plucking. So remember, the ice gets frozen to the bedrock. It starts to move and pulls pieces off that head wall. It gets steeper and steeper and steeper. A lake can form in the bottom of the cirque. This is called a tarn when the glacier ice melts. It's going to bring the pieces that's plucked off of the head wall down through the glacier as it moves, and there'll be a terminal moraine or pile of sediment at the end as the glacier recedes. So here's a bird's eye view of a cirque. Here's a cirque that has a tarn in it, these glacial lakes. Here's a hanging valley at Yosemite National Park. This is where a tributary glacier was coming into the main valley glacier. Those glaciers melted over time, 20,000 years ago, or maybe a little less than that, and left a hanging valley up here, and so a waterfall is coming out of that hanging valley. Here is Matterhorn, one of the most famous horns in the world. And here is an arête, a knife edge mountain that is, this is Mount Oberlin in Glacier National Park. Okay, glaciers also are going to be depositing sediment. The general term for all the sediment that's deposited is called drift. It's called drift. And stratified drift is going to have layers to it. It's maybe been, it has been moved by water. Bright light. It's been moved by water. And so the clasts are going to get sorted out by grain size. They're going to be rounded by the abrasion of the sediments bouncing against each other in the water. Stratified drift, which is going to be moved by ice and not water. So the drift that has not been moved by water is not going to be sorted out. It's going to be poorly sorted. It's poorly sorted. The clasts are still going to be angular. They won't have rolled downstream and gotten abraded and rounded on the edges. They're going to be deposited directly by the ice, just fall in place when the ice melts away. And that unstratified drift has a special term. It's called till. If that till is really big, it's called an erratic. And these would be like car size or refrigerator size boulders that have been carried away from their original outcrop and stayed huge and then were dropped when the glacier receded. Turn my face off for a sec. Alright, so till is unstratified sediment deposited directly by the ice. It looks like this. And this is labeled as a moraine deposit. Moraines are going to be ridges of the till that's deposited by the glacier, and the moraines are going to be deposited different places with respect to the glacier, and they'll have different names. One of those kinds is the end moraine. So this right here is the end moraine, and this shows the different ways that a glacier brings sediment down the slope and then leaves it at the toe or the terminus of the glacier. There's an internal load that is going to move through the glacier. There's a surface load that rocks are going to fall down onto the surface of the glacier, and then those are going to fall and land into the moraine. And then there's also going to be glaciers that are going to be melting, and there's going to be moving sediment away, and that's the stratified drift that carried away somewhere else. Okay, so the end moraine, turn this off again. The end moraine is here at the end of the glacier. On the edges are the lateral moraines. So these are lateral moraines. In the middle of the glacier, these dark lines will be the medial moraines. Okay, I wish I could see that image better. Sorry. This is just a dissection of the glacier, a cross section through it, the accumulation area where glaciers are going to be accumulating and not ablation's not happening. There's just snow melt continuous over time. Snowpack continuous over time. Crevasses form. These are just cracks in the glacier where the glacier curves. Cracks are going to form. Ground moraine, that's another one. A ground moraine forms at the bottom of a glacier. So this is debris that collects beneath the glacier. And then down towards the terminus is going to be the ablation area where material is sublimating off. All right, here are some lateral moraines and the medial moraine in the middle. So these two glaciers somewhere up valley came together, and then the sediment got trapped between them. Here's what a moraine looks like. It's just as a ridge of sediment. And after the glacier is gone, they can be whole mountains. Like this mountain right here is a moraine. The outwash, this it's hard to tell from this picture, but most of the picture is water. This gray here is water that is gizmo. The outwash can have all the different grain sizes of sediment mixed in. The bed load will typically be large boulders, and the suspended load would be sand and clay. And will all move about in a really turbulent flow down slope. The outwash from a glacier is called an outwash plain, and in an outwash plain you'll find really broad valleys full of braided streams. So where the stream comes towards us, I believe, and then splits around these lens-shaped islands, that's a braided stream. It splits apart and then comes back together over and over again. Braided streams are going to occur where there is so much sediment choking the river valley. Another special kind of sediment that's found, especially in the middle of the United States and up into Alaska, is called loess, Loess. And on this map, it's the orange blobs, loess, and it is sediment that is very, very, very fine-grained. Almost feels like all-purpose flour in your fingers. And that sediment makes up the fertile agricultural areas of the Great Plains. And it is the sediment that the prairie grew up on. And then when the settlers moved west and plowed up the prairie, and then the wind blew, that's when we had the Dust Bowl. And that Dust Bowl was loess dust. Loess is wind-blown sediments from the last glacial period. As that winds blew down from Canada, deposited those sediments, the prairie grew up, and then we plowed it, and then it blew again during the Depression. These are erratics, right? So on the left is an erratic in Dayton, Ohio. Just, make it part of the garden. On the right is an erratic that's one of the bubbles that sits on a hike at Acadia National Park in Maine. There are different kinds of lakes that form on in areas near glaciers. One of those is a kettle lake, and a kettle lake begins as a chunk of ice that has been left behind as the glacier recedes. So that ice is sitting out here on the outwash plain. The glacier recedes. These braided meltwater streams form around the glacier and deposit sediment on the edges of that block. And then as that block melts, what's left behind is a kettle lake. So here's that lake. So here's the sediments of the outwash plain, and then the lake forms out in those sediments. So here's a aerial view of kettle lakes. Another kind of formation is called an esker. Eskers are neat. They are places where meltwater has carved a tunnel inside the glacier. So you could kind of think of it as a river inside the glacial ice. And as that river flows through the glacial ice, sediment gets deposited within the glaciers, within the ice, and then that ice melts away, and the sediment deposited by that under the ice river left behind is going to form ridges on the Earth's surface. So in this image, this blue is water inside the glacier. Ice is green, weird color, but ice is green, blue is water. Now the ice melts away, and what's left behind, now the esker is green, is the ridge that is that those sediments that were moving in the river inside the glacier. So that's these pointy, they look almost man-made, like they would put up there by a plow or something, but those are eskers. All right, so here's a cartoon of a outwash plain. The outwash has at the head of it an esker, so the stream is inside the glacier, carrying sediment through a tunnel. And then it comes out here and loses momentum, and that sediment is going to drop out. Out here at the edge of the outwash plain are some terminal moraines, and that's going to mark the furthest extent that glacier advanced, right? These recessional moraines mark time periods where the glacier stopped for some amount of time. Depending on the size of them, you can say they stopped there a number of years, or tens of years, or hundreds of years as it receded. These kettle lakes are forming out in the outwash as the chunks of ice got trapped in that outwash, and then the main glacier receded, and then over time these chunks of ice are going to melt and leave behind a little lake within the outwash sediments. Here's just some images of glaciers. It's a pretty muddy environment, often quite foggy. Glacial ice can be really dirty. It also can be very blue, the way the ice reflects light. This shows how icy the ice is. So sometimes it kind of looks just like, almost like snow, but it's really, really ice. Here's some water coming off, the meltwater coming off the glacier.